Okay, hello everyone. Welcome back. Guys, we're going to solve quadratic equations again, this time by completing the square. Okay? Again, the quadratic has x squared, so we need to complete the square. All right, today's objective, of course, to solve quadratic equations by completing the square. The essential question: how does the technique of completing the square help us understand quadratic functions? All right? You need that for the notes assignment. Now remember, y'all, we learned how to solve a quadratic if we could take its square root. And we need to be able to take a square root in there somewhere because it's a quadratic equation. There's an x squared in there to solve for x. We have to somehow get it down. Instead of saying x squared, it needs to say x. Now in this case, if we can get it to say x minus 7 squared like that, where one side is just a perfect square, well then I can take the square root of both sides. That's what we did earlier. Okay, remember this side becomes whatever we're squaring when we take the square root. The right side is plus or minus, and then make a radical sign, and whatever is on the right side, put it underneath the radical, okay? And the reason we have to take the square root sometimes is because sometimes you can't solve a quadratic by simple factoring. Like this quadratic right here. If we try to factor it, we're looking for two numbers. You multiply them together, you get 7. When you subtract them, you get 2. Well, there's no two whole numbers like that. You can kind of see this one, okay? It doesn't quite go through even if we graphed it. I put in Desmos. It's kind of hard to tell. Even if I clicked on there, we just get kind of a decimal approximation. It's not the exact answer, and sometimes we need the exact answer. All right, we need to go far into the decimals. Well, we might be talking about something we're sending into outer space or a heart valve or something like that. We need a very good answer. All right? An approximation will not do. All right, look at these two methods here. All right, Enrique factors it. He takes the 16 to the other side, subtracting 16 from both sides. So one side is equal to 0, and he can factor it. All right, so x minus 7 is 0, so x is 7. And x plus 1 is 0, so x is negative 1. Now, Nadine over here on this right side notices that the left here is a perfect square. You can write it like x minus 3 squared. And as soon as you do that, now we can take the square root of both sides. Again, this left side here becomes x minus 3. And the right side is plus or minus the square root of 16, which is 4, okay? So you can solve it that way. So this becomes 3 plus 4 or 3 minus 4. And those are our two answers, 7 and negative 1. Okay, so that's another way to solve a quadratic equation. Once you get it into a square, you can do it that way. All right, what's completing the square? All right, you're going to get some value, a quadratic like x squared plus 6x. And then you want to add something to it to make it a perfect square trinomial. All right, this is kind of a way to show how to do it using these tiles. In this case, if we added 9 to x squared plus 6x, it becomes a perfect square trinomial. Now I can write it like that. X plus 3 squared, if I just added 9 to it. All right, now how did I find that 9? Look at 6. It's half of 6 squared. Half of 6 is 3, and 3 times 3 is 9. So the process of adding b over 2, remember b is the number in front of the x, in front of the linear term, the coefficient. The process of adding b over 2 squared to a quadratic that looks like that to form a perfect square trinomial. That's called completing the square. And that's what we're going to do here today. As completing the square is useful, but a quadratic expression, you can't factor it. All right? It can be used with any quadratic. You can complete the square in any quadratic and solve it that way. And here's one way to do it right here. Okay, you get the 6 on the other side. It becomes a perfect square. Because again, I'm adding 1 to both sides here. Add 1 to this side to complete the square. So I add 1 to 5. Now I got 6 on this side. All right, then I can take the square root of both sides. So it's okay, plus or minus the square root of 6. That's okay. Then just add 1 to both sides. All right, let's take a look at this one. I want to complete the square here so I can solve it. First thing I need to do is make it look like x squared minus 14x. Just like that. So take the plus 16 to the other side. All right, you want to make it look like this right here. ax squared plus bx equals d. Bring that to the other side. It's right here. So now we have negative 16 on this side. Once you do that, then look at b. b is the negative 14. And it's okay just to use the positive because we end up squaring it anyway. We end up with a positive number. All right, 14 divided by 2 is 7, and 7 squared is 49. So add 49 to each side. All right, that makes the left side a perfect square. Now I can write it like x minus 7 squared. All right, and add 49 to the right side. It's 49 minus 16, ends up being 33. All right, once you write it as a perfect square, now you can take the square root. And that's what step 4 is right here. Okay? And then bring the 7 to the other side by adding 7 to both sides. There's 2 answers. Again, 7 plus the square root of 33 and 7 minus the square root of 33. All right, example 3 here. This is a real world example. Talking about this hedge maze. There's one down there in Shakopee. You can walk through the corn maze. All right, the length is twice as long as the width. And they give you the total area here. 5,615 yards squared. All right, so you can write this down. It's got a 2-yard walkway. So it's 2x plus 4 times x plus 4. The length and the width. But what happens when you do this, there's a 2 in front of that x squared. You know, you cannot have that. You have to get rid of that 2. Right? You can only have x squared, so divide everything by 2, which is what they do right here. Okay, so now you have x squared plus 6x, and that's what you want. Right? You can complete the square by adding 9 to both sides. All right, and this side becomes 2809. Then take the square root of both sides. Again, go ahead and follow through this. You can see what happens at the end. Guys, remember, we're talking about distance. This is a real-world problem. All right, so there's going to be a negative and a positive answer. All right, one is 50 and one is negative 56. Well, guys, 50 is the answer, okay? 50 is the positive distance. Guys, example 4, again, you can use complete the square to rewrite a quadratic function in vertex form. All right. Again, here's an example. It starts in standard form, x squared minus 8x plus 11. All right. Subtract 11 from both sides. So this side just says y minus 11. This side, the right side here, complete the square. Again, look at the middle term here. The coefficient is 8. Half of 8 is 4. 4 squared is 16. So add 16 to this side and add 16 to the other side. Now the right side is a perfect square. I can write it like x minus 4 squared. And once you do that, this side is 16 minus 5, or 16 minus 11. It becomes 5. So then subtract 5 from both sides and bring it back. Now you have it in vertex form. All right, guys, this is just kind of a summary of everything we did here today. All right, there's a lot to cover. Make sure you understand how to write the C, how to get that C, okay? Take half of B and square it. Guys, please fill out today's notes assignment and complete the vocabulary assessment. And guys, I'm not sure if there's going to be a discussion there or not. There's going to be probably a discussion, yes, in the green folder. All right, prepare for the second Zoom meeting. We'll go over the summary assessment, which is in the orange folder. Guys, here's today's vocabulary questions. All right, so I'll get ready for them. All right, that's it. Thanks.